In this work, we introduce a study exploring different interaction modes in immersive virtual reality. With more applications now displaying full-body avatars to represent users, we are faced with the challenge of aligning the user's movements and positions of the end effectors with those of the virtual avatar. We analyze the impact of each interaction mode based on embodiment, preference, and performance. Animating full-body avatars in virtual reality involves unique challenges. The exact physical dimensions of a user and their virtual avatar may not always match perfectly. Even when they do, the avatar is animated on a simplified skeletal structure, and can't always mimic the complex movements of a human body accurately. Take, for example, stretching an arm or moving a shoulder. A user can perform these actions with a large range of motion that the avatar may not fully replicate. This difference raises a critical question for immersive virtual reality experiences. How do we deal with the mismatches between real-world and virtual controllers? Consider this demonstration. As the user and avatar stretch their arms, it's evident that the avatar can't precisely replicate the user's actions. We examine three critical factors: controller, attached, and stretch. When interacting with virtual objects, we often consider whether we should render the virtual representation of the virtual reality controllers. Whereas rendering the virtual reality controllers provides accurate visual feedback, it might not always be desirable, as we may prefer to render the virtual tool we are interacting with directly, a virtual pen for example. Also, if the virtual controller consistently stays rendered in the palm of the virtual hand, we are able to maintain multi-sensory and body continuity. However, this is at the expense of not correctly aligning the virtual and the real controllers when the avatar's arms are not long enough, which can lead to confusion or lower performance during some tasks. An option to solve this is that when the real controller extends further than the avatar's virtual arm, we can stretch the arm to keep body continuity, and the virtual reality controllers align with the real ones. After exploring all possible combinations of these factors, we narrowed down to 5 interaction modes that are most sensible in virtual reality. Next, we introduce the 5 modes used in the study. Free controller. The controller is always rendered and located in its real location, however it may break body continuity. Attached controller. The controller is rendered and always placed in the palm of the hand. Thus, the controller may not be in its real location, but we keep body continuity and multi-sensory information. Hand mode. Only the hand is shown, however, since the virtual avatar's arm may be shorter than the user's, the hand may not be in its real location. Stretch controller. The enhanced version of attached controller in which we stretch the avatar's arm when it cannot reach the location of the real controller. Stretch hand, which is similar to stretch controller, but we do not render the virtual reality controller. Our user study involved multiple stages to evaluate the interaction modes based on embodiment, preference, and performance. It began with avatar calibration to ensure an accurate representation of the participant in the virtual world. Then, for each interaction mode, participants engaged in 3 tasks: the cube task, the cannon task, and the painting task. These tasks were specifically designed to test different aspects of the interaction modes. Following each task, participants filled out an embodiment questionnaire. Participants were also asked about their perceived hand location in relation to their virtual hand or controller. This question allowed us to study later how the perceived location of the virtual hand may have affected embodiment. Once all tasks were completed, we explained each interaction mode to the participants and allowed them to explore them freely. Participants were free to change between modes and score them in a final preference questionnaire. A significant insight from our results is the importance of body continuity to enhance the sense of embodiment for virtual avatars. Both stretch and location are statistically crucial factors that impact embodiment, with stretch particularly influencing users' proprioception. We highlight the potential advantages of using the stretch mode to guarantee the accurate location of end effectors while preserving body continuity. However, a surprising outcome was that the mere multisensory coherence with VR controllers isn't the sole determinant for achieving embodiment. Our hypothesis suggested that embodiment would be higher when the controller is attached to the hand. Contrary to this, the free controller mode, despite its conflicting visual tactile feedback, yielded a higher sense of embodiment than the attached controller mode. For most interaction tasks, especially those that involve hard-to-reach objects, it's crucial to represent the controllers or hand locations as accurately as possible. Consequently, for tasks that necessitate precise virtual interactions, our recommendation leans towards virtually stretching the arm to maintain a balance of correct positioning, visual tactile, and proprioceptive coherence. Please refer to the paper for a detailed description of the results. Thank you for watching.